Okay, that's number 3. Number 4 is asking us, what is the derivative of cosecant? Is that cosecant x? Well, I don't know what this I believe they want to say cosecant, but I think they spelled it incorrectly they notated it different incorrectly here. So let me just write down number 4 here, because cosecant x is CSCX, so not COSCEX. So say, what is the derivative of this? It's cosecant x, not cosecant x spelled like this. This here is wrong. It's CSCX here. Okay, so how do you figure out cosecant x? Well, what we're gonna have to do is here is a reciprocal derivative here, or sorry, reciprocal trigonometric ratio, right? Cosecant x, we know that here cosecant x also equals 1 over sine x, right? So you can say that if f of x here equals cosecant x, you can rewrite f of x here as 1 over sine x, right? We know that cosecant x is simply just 1 over sine x from our reciprocal trigonometric ratios. And we can also rewrite f of x here. If we know that's 1 over sine x, we can rewrite this as simply sine x to the power of -1, right? So given this, what we're going to do is we're going to find the derivative, right? So in order for us to find the derivative here, we're going to set this is now f prime of x. We're going to find the derivative of f of x. So we have f prime of x equals, I'm going to bring this negative sign down, or -1 here down. That's my derivative rule. I'm allowed to do that. I have -1 here times whatever is on the inside, which is sine x here, times the chain. We're going to use chain rule here, and we're multiplying by what is inside the derivative, or what is this here. Well, what we have here is sine x, right? So what's the derivative of sine x? We all know that this here is cos x here. So this here is our kind of derivative for cosecant x here. So we have negative sine -1 times we have -1 times sine x, and what we're gonna have to do is we're gonna have to lower the exponent as well, right? So it's -1 minus 1, so obviously -2, and then we are gonna multiply it by whatever the derivative of the inside is, which is cos x here. Derivative of sine x is cos x. Fluorescent says, I love you for doing this. Well, thank you so much for tuning in, by the way. So that's what we have here. And what we can do is we can simplify this, right? We can say that we have -1 times cosine x, or we can simply just say negative cosine x. And we can simplify sine x to -2 here by simply just putting sine x squared like that. Because sine x to the power of -2 is simply just the reciprocal, is simply just 1 over sine squared x, right? So this here is our derivative for cosine x, or cosecant x. I think I'm writing on a slant here, which is kind of odd. I think I shifted my tablet differently. Sorry about that. It's kind of bothering me now. But I can simplify this even further, right? I can say that this is negative cos x over sine squared x, right? Let me just rewrite this here. And I can rewrite this, right? I can rewrite this as simply, this here is negative cos x. I can rewrite this as sine x times sine x, right? So sine x times sine x. And we know that here we have cosine over sine x. This is simply just cotangent, right? This here, cosine over sine here is cotangent, right? We know sine over cosine is tangent, so therefore cosine over sine is cotangent. So let me just write that down for you. So tan x equals sine x over cos x. So cotangent x would be simply just flipped, right? It would be cos x over sine x here. So this here would be negative cotangent x. Remember, I still have the negative here. Times, I have now simply just 1 in my numerator, 1 over sine x, which is simply just negative cotangent times negative cotangent x times sine, or cosecant x here. Cosecant x. And this here is our derivative for cosecant x here. So negative cotangent x times cosecant x. And as you can see, we got the correct answer as well. They did cosecant x times cotangent x, same thing, or negative cosecant x times cotangent x. This here is also the correct solution as well. What they did with their explanation is that they actually did a u substitution. So basically they did something that's they could do that as well, but I didn't do that personally. So they basically said let u equal sine x here. And then they would have, you're taking the derivative in respect to u. So you have u times the -1. So you're going to have f prime of u. So basically you get -1 times u to the power of -2 times the derivative of u here. And basically, and you sub u back into the equation here, and you would get exactly the same. So I skipped that step, which is totally fine, but this solution here is also correct as well. So this solution is correct. They analyzed it pretty well with the u substitution. I didn't do a u substitution personally, but this here works as well. So I'm going to say solution here is correct. Good analysis. So basically, it's just simply a chain rule within a derivative of a trigonometric ratio or a trigonometric function here. So very, very easy.